friends, myself Shivi and Dr. Kiran Yadav. In this session I will discuss about multi-stage amplifier. So the contents are, first I will start with introduction, then some important terms, then I will discuss the circuit diagram, working and frequency response, then the advantage, disadvantage and applications of multi-stage amplifiers. So first let us see what is an amplifier. Amplifier is an electronic device which amplifies the signals, voltage and current. There are different types of amplifiers such as vacuum tube amplifiers, transistor amplifier which are widely used, operational amplifier which are again widely used, and you will be studying about operational amplifiers in the upcoming units of your syllabus. Then video amplifier, then fully differential amplifier. So these are the different types of amplifier. Multi-stage amplifier is a transistor circuit in which number of amplifiers are staged and are cascaded in series. So like we have an amplifier, only a single amplifier, we give input signal to it and we get an output which is an amplified signal. Okay, so we give an input signal, we obtain an output which is basically amplified signal. So if we again feed this output signal from the amplifier as an input to another amplifier, then we can again amplify the signal to more extent. Okay, so coupling devices are also used in this process. Coupling devices are the devices which connect the output of one stage to the input of next stage. Depending on the manner in which the differential amplifier stages are connected, one of the following amplifier may result: RC coupled amplifier, RL coupled amplifier, LC coupled amplifier, transformer coupled amplifier, direct coupled amplifier. So based on what the coupling device is, these are the different coupled amplifiers. So see, at first stage in the diagram, in the orange box, this is the first amplifier. Then we introduce a coupling device in the circuit, then we introduce a second amplifier, then again we introduce a coupling device in the circuit. This is how a cascade in series is made from different amplifiers and coupling devices. So these are the circuit diagrams of multi-stage amplifier configurations. The first one is an RC coupled amplifier, then in bottom there is a transformer coupling, then there are directly coupled amplifiers. So the function of coupling device is to transfer only AC output of first stage to the input of next stage and to block the DC component. So multi-stage amplifier are basically cascaded connections. Output of one stage is connected to the input of another stage. So here we have amplifier 1 which has gain AV1. V1 is the input voltage and V01 is the output voltage. Then we have amplifier 2 which has gain AV2 and VO2 is the output from this amplifier. Then overall gain AV is equals to VO2 divided by VE11, which is equals to AV1 multiplied by AV2. So this is the voltage gain from an amplifier. So let's discuss about the important terms that are related to multi-stage amplifiers. First one is the gain, the ratio of output to input of an amplifier. It is represented by G or A. So here in diagram you can see a 3-stage amplifier. Vin is the input to first stage, G1 is the gain of first stage, so the output from first stage will be G1 Vin. Then the gain of second stage is G2, so the output from second stage will be G1 G2 Vin. Then the third stage has a gain of G3, so the output from third stage will be G1 G2 G3 Vin. In the same way, we can write if there are n amplifiers in the cascade, then the output of nth stage will be G1, G2, G3 dot up to Gn multiplied by Vin. So this will be the output from nth stage. So overall gain of multi-stage amplifier is G is equals to V out upon V in, which is equal to G1, G2, G3 dot up to Gn, which is product of individual stages gain. Now let's see the frequency response. The curve plotted between voltage gain and frequency is the frequency response. So this is the frequency response in case of amplifier circuits. Bandwidth is the range of frequency over which gain of amplifier is equal to or greater than 0.707 or 70.7% of the maximum gain. Fourth term is the noise, which basically measures the undesired noise mixed into the output. This is the circuit diagram of an amplifier. Here the R2, R3 and R4 forms the biasing and stabilization of network. Input capacitor C in couples the AC voltage to the input. The capacitor C is known as emitter bypass capacitor, and it is used to offer low impedance to the AC signal. The coupling capacitor CD couples the output of first stage to the input of the second stage, since the coupling capacitor passes only the AC signal and block the DC. That's why coupling capacitor is called blocking capacitor. Overall gain is less than the product of gain of individual stages. The second stage is made to follow the first stage. The effective load resistance of first stage is reduced because of shunting effect of input resistance. Second stage is reduced overall gain of output. Frequency response curve is plotted between frequency and voltage gain. When frequency is less than 50 Hz, gain falls. A part of AC output of first stage is lost. Lost coupling capacitor CD, which offers very high reactance at very low frequency, because Xc is equals to 1 upon 2 NFC. At very low frequency, common emitter bypass offers higher reactance that could not shut the emitter resistance Re. When frequency is greater than 50 kHz, gain falls. Beta is a transistor parameters. When Fc is high, the overall gain falls. At very high frequency, the reactance Cc becomes very small and it behaves as a short circuit. In the mid frequency range, the gain remains constant. That is, in the frequency range from 50 Hz to 50 kHz, the gain is constant. In this frequency range, frequency increases, reactance of Cc decreases, which increases the voltage gain. Decrease in reactance producing higher loading effect of first stage, which decreases the gain. The mean both of these factors maintain constant gain at mid frequency range. The advantages are it has lower cost since it employs resistors and capacitors which are cheap. It has excellent frequency response. The gain over the audio frequency range, which is the reason of most important for speech, music, etc. The circuit is very compact as the modern resistors and capacitors are small and extremely light. Disadvantages: they have the tendency to become noisy with age, particularly in moist climates. The RC coupled amplifiers have low voltage and power gain. Impedance matching is poor because the output impedance of RC coupled amplifier is several hundred ohms, whenever input impedance is only a few ohms. Hence, little power will be transferred to the speaker. Applications: the RC coupled amplifier have excellent audio frequency over a wide range of frequency. Therefore, they are widely used as voltage amplifier. So this was all about multi-stage amplifier.